Okay, so today we're going to cover section 2.2. This is all about circles. So first we're going to get that's called the center radius form. And this form is going to be x minus k squared plus, we usually use x minus h squared. So x minus h squared plus y minus k squared equals r squared. So any equation you get in this format represents a circle. The center will be ordered pair hk, and the radius will be r. So first we're going to do a couple examples where we want to write the equations of circles in center radius form. So first example, we want to write the equation of a circle. And part A, they give us that we have center at -3, 4 and a radius of 6. And in part B, they give us the center at 0, 0 and a radius of 3. So what we're going to do here is we're basically going to be plugging into our center radius form. So that's x minus h squared plus y minus k squared equals radius squared. So the x value of the center in this case is -3, so that's going to plug in for h. The y value of the center 4 plugs in for k, and 6, the radius, plugs in for r. So I get x minus a -3 squared plus y minus 4 squared equals 6 squared. And then to finish this up, so I've plugged in the center for h, the y value of the center for k, radius for there. I need to make minus negatives positive. And then I do want to square this out. So 6 squared is 36. And that is my answer for that first part. So for this part, we start from the center radius form, x minus h squared plus y minus k squared equals radius squared. They told us the center, so h is the 0 in the x value spot, and k is the 0 in the y value spot. The radius is 3. So I get x minus 0 squared plus y minus 0 squared equals 3 squared. X minus 0 is just x. Y minus 0 is just y. And 3 squared is 9. So this will be the equation of our circle in that situation. So if they tell you the center and the radius, it's pretty easy to solve the problem. Next example is going to want us to, they're going to give us the equation in center radius form. So let's say given, we'll say x minus 5 squared plus y plus 2 squared equals 4. Sketch the graph. So in this format, my center, it will be, it's x minus h, so h is 5. And then y, anytime you see a plus, that came from a minus and negative. So minus negative says that the y value of the center was -2. And then to get the radius, I take the square root of the number out here. In this case, that's 2. So to sketch my circle, and this is going to look kind of bad because I'm hand drawing it, what we do is we say, okay, let's figure out where the center is. So 1, 2, 3, 4, 5 for the x's, down 2 for the y's. And then I'm going to count from the center. I'm going to count up 2 units because that's my radius. So I count up 2 units. I go to the right 2 units. I go down 2 units. And I go to the left 2 units. And I try to connect the dots with something that looks like a circle. This doesn't look great, but whoops, well, And we just connect through the dots with a circle, and that will be our graph. So basically, if you're given the center radius form of a circle, you extract the center, extract the radius, figure out where the center is, and count the radius up, count the radius down, left and right from the center, and that'll make your graph. Okay, so moving along. We get this form called general form of a circle. And general form of a circle is x squared plus y squared plus dx plus ey plus f equals 0. It's basically just the standard form, but you FOILed it out. So the next two problems we're going to look at deal with going from kind of either general form or very close to general form back to standard form. So for this is example 3. They give us x squared minus 6x plus y squared plus 10y. Plus 18 is 0. And they want us to find the center and radius. So what this means to do is we're basically going to use completing the square, and we need to get this into center radius form first, then we can pull the center and the radius out. So I'm going to get x squared minus 6x. I'm going to put a plus blank in there to complete the square on that first part. We'll get plus y squared plus 10y plus a blank to complete the square on the y part here. And the positive 18 I'm going to push across the equal sign, so it'll turn up as a negative 18 there. The first blank I added here, I have to add that same amount to the right-hand side of the equals to keep stuff balanced. And the second blank I put there, I have to add to the right-hand side to keep stuff balanced. So we're going to find b over 2, and b over 2 squared for the x's. And then we're going to find b over 2, and b over 2 squared. We're going to find those for the y's. So for the x's, b is negative 6. Negative 6 cut in half is negative 3. Negative 3 squared is 9. So I put 9 in for x's blanks. For the y, b is 10. 10 divided by 2 is 5. 5 squared is 25, so we put 25 in for the blanks for the y's. Now the x's will factor up according to their middle number, which is negative 3, so we'll get x minus 3 squared. The y's will factor up according to their middle number, which is positive 5, so it'll be y plus 5 squared. Then that equals, let's see here, negative 18 plus 9 is negative 9. Negative 9 plus 25 is 16. So we get our equation like this, and now we just got to extract the center. If we have an x minus 3, a positive 3 is the center, negative 5 is the y value of the center. Square root of 16 is 4, so radius would equal 4. So we have the center of our circle and the radius of our circle. Okay. So we'll do, this is the last example we'll do from the book, and then there's a couple other types I wanted to look at that they turn up on tests and some places like that. So for this final example from the textbook, this is example 4 from the book. They want us to show that the equation 2x squared plus 2y squared minus 6x plus 10y equals 1 has a circle as its graph. And then they want us to find center and radius. Okay. So step 1 here, in order to do this completing the square process we did here, we're going to do the same thing again basically. I need to start out and I need to divide the whole equation through by 2. So when I do that, I get x squared. I'm going to move this x term here, so 6 halves is 3. So that'll be a minus 3x plus the x blanks. Then I'll put the y, so it's plus y squared because the 2's cancel. 10 halves, half of 10 is 5, so that'd be plus 5y plus y's blank equals 1 half plus the x blank plus the y blank. So we're going to do b over 2, and b over 2 squared for the x's. And then we'll do the same thing for the y's. We need to find b over 2. And b over 2, and b over 2 squared for the y's. For the x's, b is negative 3. Negative 3 divided by 2 is just negative 3 halves. When you square it, that's positive 9 fourths. So positive 9 fourths goes in for the x's. For the y's, b is 5. 5 divided by 2 is 5 halves. 5 halves squared is 25 fourths. So we get plus 25 fourths over here, and 25 fourths in here. So now we'll use our equation and let that do the work for us to factor up the x's and the y's. For the x's, this factors up according to the middle number, negative 3 halves. For the y's, it factors up according to its middle number, positive 5 halves. And then we got to total these up. 1 half, we should note, is 2 fourths. 2 fourths plus 9 fourths is 11 fourths. 11 fourths plus 25 fourths, all of that totals up to 36 fourths. 36 divided by 4 is 9. So this has the correct form of a circle. This is center radius form. So we know that the starting point, the starting graph, since we got it down to center radius form, we know that the graph is going to be a circle. And it will have center, negative 3 halves is going to be positive 3 halves. Positive 5 halves is going to come in as negative 5 halves for the y value of the center. And the radius will be the square root of the number here, so the radius will be 3, because square root of 3 is, square root of 9 is 3. So we get our expression looking like that. Okay, so that is the last of the 2.2 problems that we're going to look at from the textbook. There is a couple other types that we want to talk about, though, from this section. So one common one that we would see is, we'll say, suppose a circle has center 4, 2, and the point negative 5, negative 1 is on the circle. Let's say on the circle's edge. So the graph of the circle passes through it. We want to write the equation of the circle. So from what they gave us, they told us where the center of the circle is. So here's our circle. And then they told us another point that's guaranteed to be on the circle. It's on the circle's edge. And so if we really think about it, the distance between these two things is going to be the radius. So they already gave us the center. So we know if we're going to write this in center radius form, we already know the h and k part. We're missing the radius. So the center is 4, so that means h is going to be 4. K is 2. And since this point here is on the circle's edge, this point, the distance from the point to the center of the circle, that will be the radius. So if I use the distance formula, I'll get x2 minus x1 squared plus y2, which is negative 1, minus y1, which is 2 squared, the square root of that. That will equal the square root of 9. No, just kidding. This is negative 9 squared. Negative 9 squared is 81. And then this is negative 3 squared. Negative 3 squared is 3. So this will equal the square root of 84. So this is our radius. Square root of 84 goes in for radius. So when we simplify this out to get the equation of the circle, it's x minus 4 squared plus y minus k is 2. That equals the square root of 84 squared. When you square a square root, the squaring gets rid of the square root, so we're just left with the 84 out there, and that will be the equation of our circle. So that's a common type to see. The other common type, we'll do right now. This will be kind of the last problem we do from section 2.2. This type would be an example where you say, suppose, let's say here, points 3, 7 and -1, -6 are endpoints of a diameter of a circle. What we want to do is we want to find the equation of the circle. Okay. So what they've given us is we have a circle here. They've given us 2 points that are across the circle from each other, and the distance between those 2 points is the diameter. So if we use the distance formula between the 2 points, the diameter will be x2 minus x1 squared plus y2 minus y1 squared. It'll be the square root of that. So this will be -4 squared is 16, plus this will be 13 squared, which forget what that is. Like 196 or something. The -13 squared is 169. So then this is basically -9 squared. This here will be -13 squared. So if we add those two together, that plus 16 is the square root of 185. That's the diameter. If you all remember, half the diameter is the radius. So if we cut this distance from point to point in half, that'll be the radius. So this tells me the radius will equal the diameter divided by 2. So now what I need to do is I need to figure out what's the center of the circle. If we use the midpoint formula from the previous section, since these are on either edge of the circle, the midpoint of them should fall right in the center. So I'm going to calculate the midpoint. That will be the x values added together, divide them by 2. And then it'll be the y values added together, divide them by 2. And this will be, let's see, 3 minus 1 is 2. 2 over 2 is 1. 7 minus 6 is 1, so that'll be 1/2. So in our equation, x minus h squared plus y minus k squared equals r squared. 1 plugs in for h, 1/2 plugs in for k, and square root of 85 over 2 plugs in for r. So when we do this, we get x minus 1 squared plus y minus 1/2 squared equals, okay, we're going to square the top and the bottom. When you square the square root of 185, that gives you 185. And when you square 2, 2 squared gives you 4. And this right here would be the equation of the circle that's represented by that situation. And that should pretty much wrap up section 2.2. So we'll stop there and we'll cover some more next time.